see. So scientific notations is a way or a method we use to shorten writing very small numbers or very large numbers, okay? So there are sets of rules that we put in place for this. So as I said, there's something flying here, it's irritating me, sorry. Our official definition for scientific notation is a way of writing numbers that are very big or very small. Now, let's look at the difference between the two. Here, first example is for a very small number. So when we say very small, we're talking about 0,00000000053. That is quite a small number, right? And writing it all over and over again would take forever. And for a big number, we're talking about billions and millions and all of that with a bunch of zeros. That also takes quite a lot of time. So we just use scientific notation to fix that. Now let's look at the rules of this. Okay. So the first rule is we want our coefficient, the number over here, has to be less than 10. Okay, less than 10. So you cannot have a 10,5 times blah, 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 as scientific notation. No. So that number has to be less than 10. And then you put your comma and you write all of the digits which are not 0. Okay, so if you look here, I wrote my 3, but specifically I want you to look at the second one. We placed our comma after the 6, and I wrote 1, 3. So you write all of the numbers after the comma, which are not 0. Okay, but then you can leave out the zeros and you write times 10 to the power of -8 because you move the comma to the right 8 times. Okay, that's where the number comes from. So the number over here, this indicates how many times did I move my comma. Okay, so how many times I moved the comma. As you can see over here as well, it says times 10 to the power of 6. If there is no comma, it means it was at the end over there. Okay, so to get it next to the 6, we moved it 6 times because look, 1, 2, 3, 4, 5, 6. Okay, so that's what that number indicates. Now, there are positive and negative exponents. Negative exponents is if you move to your comma to the right. Okay, so moving it to the right means you're going to have a negative exponent. And if we moved it to the left, that means you're going to have a positive exponent. All right. And your base is always what? If you look at these two, times what to the power of something, what is that base always? Not the coefficient, the base of this number over here. It always has to be a 10. Thank you, Teboho. So base is always a 10 for scientific notation. You cannot have a times 5 to the power of, no, you're just making it up now. Okay, so let me check another color to write with. This, the base is always 10. Does anybody know why? Does anyone have an idea why it's always 10? Why is my base always 10 for scientific notation? Okay, let's talk about it. Okay, I'm going to write it on the side here. If I say 10 to the power of 1, how much does that give me? 10 to the power of 1, it's just 10, right? 10 to the power of 2, which is 10 times 10. How much is that going to give me? 100. And 10 to the power of 3, 1,000. Okay, does anyone see where I'm going with this? What about 10 to the power of -1? Think of the laws of exponents. This is the same as what? 10 to the power of negative 1, 1 over 10. Nice. 10, that means 10 to the power of negative 2 is 1 over what? 10 to the power of negative 2 is 1 over 10 squared, which is 100. Okay, so if you say, let's say you have something like 225, and I say times 10 squared. That's the same as saying 25 times 100, which is how much? When you're timesing with hundreds and thousands and tens, all you do is do what? Thank you, it's 2,500. So all you do is add zeros, isn't it? Whereas with this one, the reason it's going backwards is because if I say 25, I'm going to use the same thing, 25 times 1 over 10. Is this not the same thing as saying 25 divided by 10? So scientific notation is actually just timesing and dividing by multiples of 10. Okay, so do you understand why the base always has to be 10? And then 25 divided by 10 will then give you 2,5, which means we move the comma to the left one time. All right, let's get going. Okay, before I move on, I have given you a lot of information now here. So thumbs up, thumbs down on what scientific notation is on this information. Okay, I only have 2 thumbs up. There we go. That's more like it. That is more like it. Thank you. All right. So, oh, Elam, do you see why we have to learn it now? Tebogo, where did I lose you, my darling? You can unmute. You don't have to raise your hand. You can just unmute.
Ma'am,
Hmm.
I don't understand the second one.
The second one.
Yes.
The second one on the screen right now. This one for very large numbers.
Yes.
Okay. Okay, listen here, Tebogo, okay? When I write scientific notation, right, this here, that exponent will tell you where I am moving my comma. Are you with me?
Yes.
So if I have 2,5 times 10 to the power of, let's say, 4, right?
Yes.
That means it's 2,5 times 1 with how many zeros? That exponent tells you how many zeros.
4 zeros.
4 zeros, right? Which is 10,000, right? So then what is 2,5 times 10,000? Let's check. 2,5 times 10,000, guys. 85. Thank you, 1,000. All right. So do you see how this works? It tells you how many zeros you need.
I understand, ma'am. Thank
There.
you.
All right. We're going to do now some exercises to practice. We're going to practice writing it in scientific notation. And then we're going to practice going from scientific notation and writing it in numbers. Are you with me, guys? Hopefully, LM, I hope you're with me since you said it's the first time. So let us get going with this. I think putting it in practice will be a little bit more practical. Wonderful. Okay. So as you see here, okay, I have a number and I want to put it in scientific notation. So decimal notation is when it's just the number, and scientific notation is without 10 to the power of something. So if my comma was over here, there, and I want it to be next to the 6, why can't it be next to the 1? It's one of the rules that I said just now. Does anyone remember why can't my comma be next to the 1? It's one of the rules we spoke about just now. Because your coefficient has to be what? Your coefficient has to be? It's on the screen right now. Here, look here, guys. Less than 10. So am I allowed to have a coefficient of 61? 61 is definitely greater than 10, right? So my comma cannot be there. It has to be next to the 6. So step 1, when you are doing scientific notation, is you figure out where you place your comma. Okay, so your step 1 will be to place your comma. Okay, and now you need to decide, is my comma moving to the left or to the right? So if it's over here at the end, is my comma moving to the left or to the right? I want to get it here by 6. So is it going to move left or right? Look carefully where it is currently. It is here. And I wanted to move it that away. So it moves where? Thank you. To my left. So if you move, so you say move your comma left, which means your exponent will be positive. Or right, which means my exponent will be what? If I move it to the right, will my exponent be positive or negative? Negative exponent. Beautiful. Okay, so that's step 2. And then step 3 will be, firstly, you need a base of 10. So you put a base of 10. And finally, you count how many times you move the comma. There we go. So these are steps we can follow. Do you understand, guys? So let's look at my example now and see if what I'm saying is correct. Okay, so first I placed my comma. It has to be next to the 6 because my coefficient is not allowed to be bigger than 10. So I have a 6,13. I've placed my comma, right? Now, in this case, you guys said we're moving it to the left. And to the left, we said our exponent will be positive, which we have over there. Wonderful. So now we know we're going to have a positive exponent, right? Then the next thing, we put our base of 10, which is over here. And then we count how many times we move the comma. So going from there to over there, let's see. It is 1, 2, 3, 4, 5, 6. Do you guys see now where the 6,13 times 10 to the power of 6 come from? Thumbs up, thumbs down with the steps and the specific example. Do you understand what just happened now? So these steps are just a guideline of how to do it. I only have 3 thumbs up. There we go. There we go, there we go, there we go. Okay, lovely, lovely. Okay. And if you look at the next example, let's follow the same steps. Okay. Place your comma. It has to be after the 1 because if we put it after the 2, then it's 12. That's bigger than 10. Not allowed. So it's going to be next to the 1. We've placed our comma. Right? Now we decide, is this comma going to move left or right? If it's over there, do you guys see that comma? If it's over here, is it moving left or right? Thank you, Deboho. It has to move to the right. And if it's moving to the right, is my exponent positive or negative? If it's moving to the right, thank you, my exponent will be negative. Great, so now we know we have a negative exponent. Next thing, we've placed our base of 10, done. And now we have to count how many times it's moving. It's starting over here, 1, 2, 3, 4, 5. 10 to the negative 5. Beautiful. Okay, anyone have a question? No questions, we're good. Can we practice now? I think we deserve to practice now. Okay, let's get going. Let's get going. So it says, write the following numbers in scientific notation. All right. Now, let's start with A. For A, we have 134,56. Okay, we have a number. Now, here is my comma over here. I need to show you guys where the comma is. It's over there. Firstly, we have to place my comma. Which number is the comma after? Is it after 1 or after 3? Where is the comma supposed to be? Nice, Buhlali and Tebogo. Yes, we're getting it, guys. It's after the 1, so we want it to be over here. Okay, so it has to be 1, 3, 4, 5, 6. I wrote all the numbers because I told you guys you have to write every single digit that is not a 0. You have to write it. Okay, so I have 1, 3, 4, 5, and 6 times. What base are we using again? Times what? What is my base? Thank you. Times 10. Now, did I move my comma left or right? Did I move my comma left or right? I moved it to the left. So is that a positive or a negative exponent? Beautiful, positive exponent. Okay, what's next? How many times did we move our comma? How many times did we move our comma? Look where it was and where it is now, guys. It was at the blue. It was over here. You have to look at where the comma is, right? There we go. We moved it twice. Don't look at the whole number. It was 134. It wasn't 13,000. It was 134. So we started here and we went 1, 2. So then my exponent is times 10 to the power of positive 2. All right. Are we with me? Okay, I don't see any questions. So I'm going to do the second one and see if we are sort of getting this. Okay, we have B. Okay, if I'm going to rewrite this, I need to count how many zeros we have here. Comma, 1, 2, 3, 4, 5, 6 zeros. 1, 2, 3, 4, 5, 6, 5, 6, 7, 8. Okay, step 1, place my comma. After which number do we want the comma? After the 5. So I'm going to have 5, comma, 6, 7, 8 times. Which base are we using after the times? 10. Are we moving the comma left or right? Right, so my exponent is negative. And how many times are we moving it? We're starting over here. We want to be over here. Okay, let's count. Let's count, guys. We're starting there. 1, 2, 3, 4, 5, 6, 7 times. 7 times. Those who said 8, I have a feeling it's just a counting error. Maybe the screen is a bit small and you can't see the zeros. But do you guys understand? After those 2 examples, thumbs up, thumbs down before we do the last 2. It's very important that you guys get this. Wonderful, wonderful. Remember, if you don't understand, just put a thumbs down. Don't be shy. Okay, great. Okay, let's do the last 2. Number C. 8, 7, 6, 5, 0, 0, 0, 0, 0. We said if the comma is not visible, then where is it? If I don't see a comma, then where is it? I'm saying currently. We do want it to be here, but currently, where is it? Because I don't see any comma in this number. At the end, beautiful. Yes, Butlali, guys, it's here. Okay, so currently the comma is over here. Okay, so who said it? Debocha told us we want it to be after the 8, so it's going to be 8, comma 765 times 10. Now, if it's over here and it's going there, is it moving left or right? Is it moving left or right? It's moving left, which means my exponent is going to be positive. I don't have to write a plus. It's just a positive number. Now, let's look carefully. How many times are we moving this comma? Logan says 8. I'm going to count just now. Okay, looks like we all agree. 1, 2, 3, 4, 5, 6, 7, 8. So then my exponent is positive 8. Okay, let's do the last one, number D. And it is 0, 0, 0, 1. Where do I want my comma to be? Where would I like my comma to be? After the 1, right? So I'm just going to write a 1 because I know it's after this. It's there. Okay, you don't have to write comma 0. You can just write 1 times 10. Are we moving it left or right? Are we moving it left or right? We're moving it right. So my exponent is negative. And how many times am I moving it? 3 times. Negative 3. Done. Final thumbs up, thumbs down. How did this round go for us? Ooh, I even got a celebration. That is fabulous. Thank you. Boo, 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 boo. That's how I used to do it last year. Boo, 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 boo. My family's probably thinking, what the hell is going on in there? She's supposed to be teaching. Okay. Now, let's go backwards. No, not yet. Not yet. First, we need to answer, are these in scientific notation? And I want you to tell me, if you say no, you must tell me why you're saying it's not in scientific notation. And then we're going to fix those ones that are not in scientific notation. Are we with me? Hopefully we are with me. So let's go. A, is A in scientific notation? No. Why not? Why not, guys? Anyone? Thank you. That number is bigger than 10. Do you see the comma is after the 0, which means it's 90, comma 3. That is not scientific notation. Okay? We want the comma to be where? Where do we want the comma to be? After the 9. So it has to be 9, comma 0, 3. I said don't write the zeros, but I meant after the number. You have to write comma 0, 3 here, ne? Because comma 3, 0 and comma 0, 3 are not the same. Are we listening, guys? If the 0 is between numbers, if I have 1, 0, 4, 3, you cannot just make this 1, comma 4, 3. This 0 is between other numbers. So you have to write 1, comma 0, 4, 3. Are you with me? Because 1, comma 5 and 1, comma 0, 5 are not the same. Do you guys understand what I'm saying? Okay, we're very quiet, so I'm going to just assume that we understand what I just said. Okay, wonderful. Thanks, Buhlali. So if the 0 is between numbers, you write that 0. So it's 9,03. Now, we have already times 10 to the power of -5. But now we're going to do our own times 10 something, right? Did we move the comma left or right? Did we move my comma left or right? Left, how many times? Is it positive or negative? Excuse me. Is it positive or negative? It's going to be positive. Positive what? How many times did we move it? Look carefully. We moved it once. And do we generally write an exponent of 1? No, we don't. But now I want us to look at something here. Are we done answering this question? Do you think this is acceptable here? Over here. Do you guys think it's acceptable the way it stands? No. What can we do about this? What do we know about the laws of exponents? I have a base of 10. I have a base of 10. What am I allowed to do with my exponents, seeing that I am multiplying? Ha! We're adding exponents. So I'm going to say 9,03 times 10 to the power of -5 plus what? We didn't put anything there, but we said the exponent is, if there's nothing there, it's a 1. So my final answer is then 9,03 times 10 to the power of, and then integers come in. What's -5 plus 1? Beautiful, Deboho. I see your message in my DM. -4. Beautiful, guys. Okay, let's do the next one. Is B in scientific notation? B, is it in scientific notation? No. Where do we want our comma? We want it after the 1. So I'm going to write B here. So we want 1. We don't have to write comma 0, 0, okay? Now I already have a 10 to the power of 2 times 10. Did we move our comma left or right? From 100 to 1. Did I move my comma left or right? Left, so the exponent is positive. And how many times did I move it? Remember, it was at the end there, and we moved it to there. How many times did we move it? Twice. Now let's add our exponents. It's going to be 1 times 10 to the power of 4. Nice, guys. Is number C in scientific notation? Number C, yes it is. So there's nothing we can do about it, okay? I'm just going to write, yes. Number D. Is number D in scientific notation? Yes, it is. Number E. No, because 0,01 is less than 1. That's too little. Okay, so let's move it. Where do I want my comma? Okay, I'm going to say no. We want it after the 1. So I'm going to say 1 times. The 10 to the power of 3 was already there, times the new 10 that we're doing. Now, did we move this left or right? Did we move this left or right? Right, so my exponent is negative. And how many times did I move it? Twice. Beautiful. Okay, now let's add our exponents. That means it's going to be 1 times negative, yes, 3 plus -2. What happens when you do the plus minus? 3 plus -2. This positive negative gives us a what? A negative. So then my exponent is what? Nice. 4. 3 plus -2 is 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 4. 3 My exponent is just 1. Guys, be careful. Remember, it's 3 minus 2, not negative 3 plus 2. So it's 3 minus 2, which is what? Just 1. Do I have to write that one? No. So we're done, essentially. Okay. And number F, is it in scientific notation? Look carefully at number F. No, remember this coefficient here has to be greater than 1. So it has to be less than 10, but it has to be greater than 1. Okay? So let's see. Where do we want my comma? We want our comma after the 6, right? So it's 6, then we have times the 10 to the power of 8 that was already there, times, did we move this comma left or right? Right, so my exponent is nice Tebogo and Logan, negative. And how many times did we move it? Beautiful, guys. Beautiful, beautiful. Once, okay? So then it's 6 times 10 to the power of 8 plus negative 1. What does this plus negative do? That positive negative becomes a negative. So it's 8 minus 1. So then I have 6 times 10 to the power of 7. Beautiful. Thumbs up, thumbs down on this whole question. Must I zoom out for people who want to screenshot? There we go. Beautiful, guys. We're doing well. We're doing really, really well. Okay. Now, what if we're going the other way around? What if I'm going the other way around? Okay. Now we've been given scientific notation, and we must write it as normal numbers. Okay. So now let's look at A. 1,95 times 10 to the power of 4. Okay, so now do you guys think we're going to move this comma left or right? We're going the other way around, remember? This is the opposite of what we just did now. So we're going the other way around. So am I going to move the current comma where it is? Am I going to move it left or to the right? Oh, nice, Fuhlali. Do you guys understand? We're doing it the other way around. So now we've been given the scientific notation. Maybe I should go on the side and have a little bit of an explanation here. Okay, so initially, if I had 1 comma, no. If I had, let's say I had 1, 2, 4, 7, 0, 0, 0, and I said, put this in scientific notation. Where were we going to move the comma? This is when you have a number, right? Where were we going to move this comma? After the 1, right? So is that left or right? It is left, right? But now I have been given the comma there, and I wanted to go back to this number. So where should I move it? We're doing opposites now, right? Where should I move it now? If I've been given the comma in the right place, and I'm saying to you, put this number back to the way it was. So if I was moving it left, now I'm going to move it. Nice, Tebogo. I see your answer and Buhlali. Now I'm going to move it to the right. Okay, so it would be 1247 times 10 to the power of 1, 2, 3, 4, 5, 6. Do you see that? So now I'm going to take the comma, which is at 1,247, and I have to move it to the right 6 times. Now, what's happening if we run out of numbers here? 1, 2, 3, but I still have to move it 3 more times. So what do I put there as placeholders? Look at the original number. If I run out of spaces to move my comma, nice, I put zeros. Okay, so I've moved it 3 times. 1, 2, 3. So then the number is 1247 with 3 zeros. Thumbs up, thumbs down. Do we understand the opposite of what we were doing now? Now we're going in the opposite way. Okay, I see some thumbs up, but not nearly enough. I feel like some of us are still a bit nervous. Now you're doing the opposite, guys. So if you're given the number, you go one way. But if you're giving the scientific notation, you go the opposite way. Okay, so let's go the opposite way. Let's see if we understood what I just said now. So initially, now we have a positive exponent. So am I going to move to the left or to the right? We're doing opposites now. Am I going to move to the left or right for number 1? To the right. How many times? It's still in the exponent. How many times am I moving right? You still look at there. Look at your exponents, guys. How many times are we moving? There we go. 4 times. But do we have 4 numbers to move to the right? So what do we place? Zeros. Okay, so how many zeros do we need? Let me move it. I'm going to move it 1, 2. So how many zeros do I need in order for my comma to move properly? How many zeros do I need to add to this number, guys? Look carefully. I've already moved 1, 2 times. I need to move how many more times if I've already moved once and twice? I still need to move 2 more times. So how many zeros do I need to add? Think carefully. 2. Nice, Butlali. So then it'll be 1, 9, 5, 0, 0. And if you're not sure, start again where the comma was in the first place. It was over there. 1, 2, 3, 4. That's your correct. That's your number. So then this number is 19,500. Let's do number B. Opposites again, negative exponents. So am I going left or right? We're doing opposites again. Am I going left or right? Think carefully. Nice, Tebogo. I see your answer. That's correct. Are we going left or right, guys? Left, guys. Remember, initially with negative exponents, where were we going? Initially with negative exponents, where were we going? Let me show you guys. Negative exponents, we were going right. So if we're doing the opposite now, negative exponents means we're going left. Do you see? So I am starting with 5, 5, 3. And I am moving that way. Okay? So I only have space to move once. So what do I have to add before that 5? A 0. So it's 0, 5, 5, 3. And the comma is there. Does that look normal? Does that look like a normal number, guys? No, so what do I still need to add before this comma? Another 0. Okay, and remember, if you're not sure, start where you were. You were here, and you moved 1, 2. Okay, you cannot add 1, you just add the 0. Okay, it just means it's a small, small number. Okay, guys, let's do the next one. I have a brain break, guys. I promise you we'll go to brain break just now. Let's just do C and D, and then we're going to brain break. Let's do number C. Again, we have a negative exponent, so are we going left or right? We're going left. Oh, I forgot to write the exponent here. Times 10 to the negative 2. 10 to the power of negative 4. We're going left. How many times? Let's look at our exponent. I hate dark pink because you can't see past it. How many times are we moving left? Nice. They were 4 and uhlale 4 times. How many zeros does it mean we have to add before this 5? How many zeros do we need to add? Remember, you're over here. Okay, let me do this. 5, 1, 4. If I'm there and I go 1, 2, 3, 4. So how many zeros is that before the 5? 3. So it's 0, 0, 0, 0, 5, 1, 4. And then number D, which is the last one. This is 4, 9, 3 times 10 to the power of 7. Are we going left or right? Are we going left or right? Remember, now we have a positive exponent. Nice, Tebogo. Okay, we're moving right. We have to move 7 times, but I only have 2 numbers, 1, 2. That means how many zeros am I adding after this number? Nice. 4, 9, 3. 1, 2, 3, 4, 5. So that is what? 49,300,000. Okay, on the last 4, thumbs up, thumbs down, and then we can have a quick brain break. The last 4, thumbs up, thumbs down. Okay, beautiful. Let's have a brain break, guys. My brain is tired also. Okay. First question, if you multiply this number with any number in the world, the answer will still be the same. What's this number? Does anybody know? Anyone want to participate in this? Let's hear. People are saying 1. Does anyone have a different answer? The answer will be the same every time. Guys, let's think about 1. 1 times 2 and 1 times 3. Is that going to give you the same answer? Oh, Wade is onto something. Wade, you are onto something, my darling. If I say 0 times 50 and 0 times 150, what is the answer for 0 times 50, guys? 0. What is the answer for 0 times 150? 0. So our answer is beautiful. Wait, the answer is 0. No matter what you multiply it with, you will always get the same answer. Okay, next one. Does anybody know which domino is next? Remember, Tebogo, we said multiplication, not powers. Okay, so be careful with that one. Okay, does anybody know which one is next? 10 doesn't work. Uhlale? Because 1 times 10 and 2 times 10 will not give you the same answer. Okay, they have to give you the same answer every time. All right, guys, between A, B, and C, which one's next? Guys, what do you mean by 10? I'm so confused. Oh, B. Oh, is that what you were saying, Buhlale? Are you saying they were adding up? Oh, I'm sorry. I misunderstood. Okay. So you guys are saying they should add up to 10. But guys, do these add up to 10? 2 plus 0, 3 plus 1, 4 plus 2. Ah, guys, no, these are not adding up to 10. Someone did send me the right answer though. Ilham, how did you know the answer is C? You're correct, but how did you know the answer is C? Guys, what do you mean by the 10? I'm very confused. They don't add up to 10. Bohlale has seen it. Do you guys see what's going on?
Because it sounds like he's counting.
Because it's
It sounds like we're counting.
not really. You're close, but not really. Okay, I want you guys to see this properly, ne? To go from there to there. So we're starting at 0, 1, 2, 3. So the one at the bottom has to be what? 0, 1, 2, 3. This one has to be 4. Okay, same thing this side. 2, 3, 4, 5. So the one at the top has to be 6. So the only one here that has a 4 and a 6 is option what? Is option C. So Ilham was correct. It's C, guys. Okay. And the last one, which one is the next shape in the pattern? This one is easy, guys, I promise you. Which one is I almost said which one is easy, wow. Which one is next for this one? Okay, Buhlali says C with a question mark. Neo says C. Does anyone have a reason for their answer? Does anybody have a reason? It adds up. Buhlali, please unmute. What do you mean it adds up? Adds up to what? Oh, that is true. A circle has how many sides, guys? A circle has how many sides? It's not 0. There is a side because it exists. But it is one long side. Do you guys see that? So it's one side. And then the B, well, not the B, the second one has how many sides? This has 2 sides. And then here we have how many sides? 3. And then we have how many sides for the next one? 4. So which means which one should be next? Something with 5 sides. And that is option C. Dum, dum, dum. Beautiful. Okay, let's do one more question that I want us to do that has to do with scientific notation. This one. Okay. Now says calculate the following. Ilham is like, but how? Because a circle is just one big side. It stops and ends without lifting your pen. So think about it. You can just So it's just one long side. Okay. Okay, let's do these, guys. I think we only have time for one more. Now, we have a problem here because we're adding. Do you guys see that? But you can only add what? What's that magic word that we give to stuff you can add? What can we add, guys? They have to be anyone? No. Are we allowed to add the exponents? Remember, look at the operation we're working with here. This is a plus. So are we allowed to add exponents? No. But there is something we can add. Can I add x plus y? No, because why can't I add x plus y? Nice. Tebogo says it privately in the chat and you are genius. Thank you. They're not like terms. Thank you, Buhlali. They're not like terms. So now here we want like terms. And how are we going to get like terms? By having the same what? By having the same exponent. That's the only way we can add those like terms if they have the same exponent. So now how am I going to change these exponents to include like terms? Is it possible for me to take this 3 and make it an exponent of 5? Do you guys think that's possible? Because this number ends at 230, right? No, it's not possible. So now I am forced to change this 5 to a 3. So am I going to move my comma left or right if I want this exponent to decrease? What do you guys think? Am I going to move this exponent left or right if I want my exponent to go lower? Come on, guys. To the right. Nice, Tebogo. How many times do I have to move it? How many times do I have to move it, guys? Oh, is my connection bad? Sorry, guys. I'm saying I'm moving it to the right, but how many times would I have to move it? Twice, right? So then it'll be 716 times 10 to the power of 3 plus 2 comma 3 times 10 to the power of 3. And now they are like terms, so we can add the coefficients. So what's 716 plus 2 comma 3? 716 plus 2 comma 3. Yeah, there's probably a problem with the network or something. This is going to be 7. I'm going to just say the answer because we're out of time. 718 comma 3 times 10 to the power of 3. Nice, guys. And that's the end of our lesson.